In the previous class, I have discussed two things, two concepts called one is called the CPLD, second is FPGA. CPLD is the complex programmable logical device. Next is FPGA. FPGA is the field programmable logic device. In the field programmable logic array, basically the FPGA is an integrated circuit that contains 64 to over 1000 identical logical blocks. There is a combination of logical blocks viewed as standard components. Like CPLD, programmable logical device, complex programmable logic device. FPGA contains neither NAND nor flag. It contains the three basic blocks. They are the configurable logical block, CLB, IO block, and programmable interconnect. I have undergone these configurable logical block as well as the programmable interconnect. What are the blocks, what are the things are there in the programmable interconnect, and what are the things in the configurable logical blocks. Also it includes the circuitry, clock circuitry, additionally ALU, memory and decoder may be available. Okay, there are two basic types of the programmable elements. There are two basic types of the programmable elements. They are the static RAM and anti-fuse. Only one more is the flash. Okay, these three are there. We'll go in detail to the static RAM and flash as well as the anti-fuse. Each logical block in FPGA has a small number of input and output pins, and it has also logical lookup table is most commonly used type of the logical block used within the FPGA. That LV logical block consists of basically it is implemented using the lookup table methodology. There are two types of the FPGAs. One is called SRAM based as well as anti-fused technology based OTP, one-time programming. Okay, it is a basic architecture. I have discussed these things. Three basic elements: configurable logical block, IO block, and programmable interconnect. In the CLB, basically the CLB consists of configurable logical block consists of the combination logical section of the block capable of implementing any Boolean function. It consists of combinational logic as well as the storage register. The CLB consists of the CLB configurable logical block consists of the combination logic and storage element. This combination logic section of the block is capable of implementing any Boolean function of its input variable. Registers can be used to load from a combination logic or directly from the CLB input to the register output. Okay, the programmable interconnect. The programmable interconnect, it is in the FPGA, three types of the metals resources are provided to fulfill the various network interconnect requirement. There are the three basic types of the programmable interconnect. One is called general purpose interconnect, second is direct connect, and third is the long line or multiplexer base buses and wide and gate. Okay, there are the three types of the interconnects. In the general purpose, there are total 5 horizontal and 5 vertical segments are there. Okay, each segment is the height and width of the same as a logical block. The switching matrix joins the ends of these. Okay, there are 4 vertical lines and 4 horizontal lines are there. And the lines are through the switching matrix we have been interconnecting. Okay, that things in the direct connect. In the direct connect, basically two directly connected. Directly we have been connected to the one CLB to the another CLB without going to the switching matrix. Okay, in the long line, they have been basically each interconnect columns has 3 vertical lines and two horizontal lines, two vertical and three horizontal lines. Long lines are there as just indication of that. To each CLB, in between the two CLB, two vertical and three horizontal lines are there in the long line. Okay. Next today's topic will be the technology mapping for FPGA. What is meant by technology mapping? What is the importance of this? We'll see that. Okay. First, technology mapping. The high functionality of FPGA logical block presents a new challenges. Okay. We required a functionality. We need a high functionality at the output side for logic synthesis. So the technology mapping provides a solution for the FPGA that uses a lookup table to implement a combination logic. Okay. Finally, we comes a thing called the mapping using the three different things. One is called the basic thing. Almost all the FPGA they use the lookup table method. Lookup table mapping. Second is the library. Third is the multiplex. Okay. First we'll go for this lookup table. What is meant by lookup table? How to implement all these things. Okay. First is a technology mapping is a process of transforming a technology independent Boolean network into a technology dependent network. It is a mapping, a process transforming a technology independent Boolean network into a technology dependent network. Okay, here for example, for a k input lookup table, LUT lookup table is a digital memory that can implement any Boolean function of k variables. For example, say a two input variables. The two input variables. Say I am going to design a two input variable in the lookup table. Say for example, for an AND gate 0 0 0 0 1 1 0 1 1. Say these are the inputs A and B, a possible output 0 0 0 and 1. These things are stored in the lookup table. These things are 0 0 0 1 is stored in the lookup table. When a possible input comes, depending on the inputs, I have to select the output itself. Only output is stored in a memory location in the table. Based on the input combination, I am going to select a output. Final thing is, from the lookup table, I will store the output combinations based on the input selection. Okay, that is based on the number of inputs. So combination output. For example, n input lookup table is a digital memory that can implement any Boolean function of a k variables. K is two variables. It can implement two variable outputs also. Okay. Technology mapping is a logic synthesis task that is directly concerned with selecting the circuit elements used to implement the optimized circuit. Okay. Finally, for an optimized circuit, simply I have shown only AND gate. For an optimized circuit, for an entire logic design, I have stored a desired output level. Based on the selection, I will select a particular output. Okay. Previous approach to technology mapping have focused on using a circuit elements from a limited set of simple gates. Okay, only using an AND gate or an OR gate or AND gate, using the limited set of gates. Okay, it is entire circuit. It has been stored in the memory location. However, such approaches are incorporated for a complex logic block where each logical block can be implemented a large number of the function. Okay, next. In this basic thing, first we'll go for the library based technology mapping, then we'll go for the lookup table. In library based mapping, gates or components are selected from the technology library to implement a circuit. Already a pre-designed components are there. Predefined components, gates are available. Only we have to drag that component or we have to drag that gate for implementing our design. That is a library based technology mapping. Hence it is also referred to as a library building, so that this method generates a technology mapping for a given Boolean network using a characterized cell library with the objective of cost optimizing and delay optimization. Finally, the thing is already a pre-designed things are there. That means the design things no need to go for a designing that cell. That means the designing cost will be reduces as well as the delay optimization. The delay time for the design will going to be optimized. That when we have a library based technology mapping, the two things, one is called optimizer, cost optimization, and delay optimization with respect to the design only. In this method, the set of the available circuit elements is represented as a library of a function, and the constructed of the optimized circuit is divided into 3 sub-programs. One is the decomposition, matching, and coupling. Okay, these are 3 different steps. The original network is first decomposed into the canonical representation that uses a limited fan-in NAND node. This decomposition guaranteed that there will be no nodes in the network that are to be large to the implement by any library element, provided the library including NAND gate that reaches the fan-in line. Just it is a network, already predefined gates and components are there in the library. Okay, next is the LUT, that is lookup table based technology mapping. It is an important thing. One is the LUT based technology mapping. It is called the lookup table based technology mapping. The limitation earlier technology mapping approaches prevented the way of the developing of the technology mapping that deals specifically with the LUT circuit. The first LUT based technology mapping approaches in the 1990s. The later improved for a optimized delay performance of a LUT circuit by the minimization number of the levels of the LUT in a final circuit. Okay, if you increase the number of inputs, the combination also increases based in the new technology, based on requirements it has been designed. Okay, in LUT based FPGA, for example, the Helix FPGA, the building block of the LUT is building blocks of that the Helix is a lookup table as well as a flip-flop. In LUT based FPGA chip, as a basic programmable logic block is a k input lookup table which can implement any Boolean function of a look to k variables. It is purely based on the k input variables only. What would be the output? For a combination of input, what should be the output? The technology mapping in lookup table based FPGA design is to be the cover a general Boolean network using a k lookup table to obtain a functionality equivalent k lookup table network. The main objective in the lookup table mapping are, okay, cost optimizing mapping, that is minimizing the number of LUTs and minimizing the number of CLBs. Okay, the basic thing is optimization with respect to the lookup table is with respect to the minimizing the number of CLBs, configurable logical block. Delay optimizing mapping, that is minimizing number of LUTs levels and minimizing delay, including a routing delay. Okay, for the CLBs we have to route the one CLB to another CLB. Okay, for designing things, and the routing delay is going to be reduces when we go for a lookup table. Maximizing the routability of the mapping scheme. The LUT based technology can be implemented using 2 types of the algorithms. They are, one is called the area algorithm and delay algorithm. One is called they are the 2 approaches of the designing the LUT are the one is called the area algorithm, second is the delay algorithm. Okay, next type is the next approach is the multiplexer based technology mapping. Okay, this multiplexer based technology mapping is used in ACT, ECL, FPGA and recent Zenix VIRT Vertex 6 FPGA device. This multiplexer based technology used in ACTEL, ACTEL and vertex 6 FPGA device. Because their logical blocks architecture are MUX based, the logic block architecture are purely based on the multiplexer, that is for example 2 to 1, 4 to 1 multiplexer based. We have based on that. Actel based FPGA, the size of the multiplexer is small and suitable to achieve the objective of area optimization and minimize delay. Final requirement is only two things. Two basic objective is, one is the area, second is the delay. Okay, when delay is there, then automatically speed is increases. Area is there, area optimization of area, that is reducing the area. Okay, automatically occupying of the space occupation of the IC also reduces. Okay, two basic achievement objectives, whatever the IC, they are objective achievements, optimization with respect to the area as well as the delay. Okay, the circuit usually contains a large number of the multiplexers. This is mainly true for the circuit that are automatically synthesized from high level descriptions. MUX exists in the data path of the circuits, where they are used to route operands to operand. Also, control logic is frequently specified as a case statement in HDL description, hardware language description. The MUX arises as a result of a direct translation of case statement in HDL into logic level description. The main objective behind this MUX based on technology mapping is describing a combinational circuit in terms of the Boolean equations and realizing its using a minimum number of the basic blocks of the target MUX based on architecture and minimizing the delay on the critical path. In this algorithm, an appropriate base function, a library cell and a set of the pattern graphics are selected. This MUX is based purely a selection purpose only. The advantage of MUX based technology mapping are its guarantees the optimal mapping, which are often much better than those produced by the conventional hierarchical technology. Moderate larger circuit can be mapped optimized in a small amount of the time. Very large circuit can be mapped near optimized by the partitioning the circuit and mapping the each portion individually. Okay, this is about the three technology mappings. Now, program technology, there are the number of program technology have been used reconfigurable architecture. Each of these technology have different characteristics, have significant effect on the programmable architecture. Some of well-known technology are, one is called, previously I have discussed these things, two things are there, especially there are three basic things are there. One is called static RAM based programming technology, flash programmable technology, that is EEPROM, and anti-fuse programmable technology. We'll discuss a little bit this and then wind up these things, and next class onwards I'll go for the whatever things left over in the fourth model, that is pseudo NMOS and dynamic NMOS things are there in the next class. That means on the Tuesday I'll wind up your syllabus. These are the three basic programming technology. One is static RAM, flash programming and anti-fuse. What is meant by static RAM based programming technology? Static memory cells are the basic cells used for the SRAM based FPGA. Okay. Most commercially vendor like Xynix, Lattice, etc. are the use static memory based programming technology in their device. These devices use static memory cells which are divided throughout the FPGA to provide a configurability. Okay. Programmability is based on the read-write memory. Programmability, configurability, it is purely based on the concept called RAM is the read-write memory, a static RAM. It is statically. Okay, there are two primary uses of a static RAM cell. Most of them are used to set the select line to multiplexer that states the interconnect signal. The majority of the remaining static RAM cells are used to store the data in the lookup table that are typically used in static RAM based FPGA to implement the logical function. Historically, SRAM cells are widely used to control the tri-state buffer and a simple pass transistor that were also used program interconnect. SRAM based program technology has become the dominant approach for the FPGA because of its reprogrammability and the use of a standard CMOS process technology, and therefore leading to increase the integration, high speed and low dynamic power consumption of a new process with smaller geometry. Okay, overall thing is called the in static RAM based technology. The thing is that memory elements purely based on the SRAM CMOS process. It is called reprogrammability. Whatever the data stored in memory, we can read as well as write. The thing is that reprogrammability. It increases the integration and high speed. When we have a CMOS technology, it has a high speed, low dynamic power consumption. Okay, of a new process within a smaller geometry. With smaller geometry is the area with respect to the area. There are, however, a number of drawbacks associated with the static RAM based program technology. What are the drawbacks? Okay, each cell in the, for example, an SRAM cell requires 6 transistors, which makes this technology costly in terms of area and other programming technology. When we have to store a 1-bit information, requires a minimum 6 transistors. To store the 1-bit information, it requires 6 transistors. To read or write a data, 1-bit data, it requires 6 transistors. It is costly. And so as area occupation, when you have a dynamic RAM, only single transistor is sufficient to store the data. It is required refreshment is required in the dynamic RAM. That is the thing is there in the DRAM. Further, SRAM cells are volatile in nature, and external devices are required to permanently store the configurable data. Volatile in nature. Okay, these external devices adds to the cost and area overhead for a SRAM based FPGA. There the drawbacks of the SRAM is, one is called the it is due to the volatility, extra cost is required, extra area overhead is there in the SRAM based technology. Next is flash programmable technology. The same thing. An important alternative to the SRAM is the basic program technology is the use of the flash, that is electrical erasable programmable read only memory, EEPROM basic technology, basic programmable technology. This technology inject a change into a gate that floating above the transistor. This approach is used in the flash or EEPROM memory cell. These cells are the non-volatile. They do not lose information when the device is powered down. Only in the static RAM it is a volatile. That means when we power down, whatever the data they may lose. Okay. In the EEPROM it is not. It is a non-volatile. When we power down, the data is it will be retained in the memory itself. And with a modern IC fabrication process, it has become possible to use the floating gate cell directly as a switch. Flash memory cell is particularly are now used because of their improved area efficiency. Okay, thing is the drawback of the area only in the flash memory, and the widespread use of the flash memory cells are for the non-volatile memory chip, ensuring that flash manufacturing process will benefit from the stand by decreasing in the process geometry. Flash-based program technology offers several advantages. For example, this program technology is a non-volatile in nature. The basic thing is flash memory is the non-volatile in nature. Flash-based technology, flash-based program technology is also more area efficient than SRAM-based program technology. When compared with an SRAM, the area occupied flash memory is less. Only it is read-only memory. Okay, that is the reason it is less occupied space. Less transistors are required. Flash-based technology has its own drawbacks also. Unlike SRAM-based program technology, flash-based technology cannot be reconfigurable, reprogrammable, and infinite number of times. Only a limited number of times it can be reprogrammed. The flash-based program technology, a limited number of reprogrammability, reconfigurability. It cannot be an infinite number of times. One of the drawback of flash-based program technology is also flash-based technology with non-standard CMOS process. It is not the standard CMOS-based technology. And this flash-based program technology offers several unique advantages. Most important, non-volatility. The future eliminates of the need of the external resources required to store the and load configure data when SRAM-based technology is used. It's the flash-based device can function immediately upon power on instead of having a wait of the loading or configure data. A flash approach is a more area efficient than the SRAM-based technology, which requires up to the 6 transistors to implement the program storage as in the SRAM. Programmable circuits such as the high and low voltage buffer need to be programmed. The cell contributes the area overhead not present in the SRAM-based technology. Okay, finally is the anti-fuse program technology. An alternative to the SRAM and floating gate based technology is anti-fuse programming technology. Okay, what is meant by anti-fuse programming technology? What are the advantages? What are the drawbacks? We'll see. Within 2 minutes, I'll wind up. This technology is based on the structure which exhibits a very high resistance under normal circumference, but can be programmability low in reality create a low resistance link. An anti-fuses is in a 2-terminal device with an unprogrammed state presenting a very high resistance between its terminal. When a high voltage from 11 to 12 voltage depending on the type of the antifuse is applied across its terminal, the antifuse will blow and create a low resistance link. Okay, it creates a low resistance link between the terminals. This link is permanent. This link is the permanent link. Once you have created a link, you cannot disconnect. Programming an antifuse requires extra circuitry to deliver the high programming voltage and a relatively high current of 5 milliamperes to the or more than that. This is done through the fairly scalable pass transistor to provide a address to the each antifuse. Antifuse technology is used in the FPGA from Actel, Fick, Logic and Crosspoint. The major advantage of the antifuse is that its small size, little more than the cross section of the two metal wires. Okay, it is when we cross one metal to another metal, whatever the area occupied, it is less than that only. But this advantage is limited by the large size of the necessary programming transistor, which handles a large circuit current and includes the isolation transistor that is sometimes need to protect low voltage transistors from high performance voltage. The second major advantage of antifuse is the reality low series resistance. That on resistance of the device is low, that is 300 to 500 ohms, while the silicon wafer it has an 50 to 100 ohms. Additionally, a parasitic capacitance of an unprogrammed amperes antifuse is significantly low than that of the programmable technology. The limitation of this technology does not make use of the standard CMOS. Antifuse will not going to use the CMOS technology. Antifuse programming technology based device cannot be reprogrammed. Okay, once we have programmed permanently it cannot be reprogrammed. The identical technology should be reprogrammable, non-volatile, that uses the standard CMOS technology, but it is the clear that none of the above technology satisfy this condition. Okay, basic condition is we required a non-volatile and standard CMOS process is required. Okay, in one case, that in the SRAM based, it is the volatile in nature, but it is used as a CMOS. In flash type, it is volatile, non-volatile, but it is not used as CMOS. In the antifuse, it is the permanent. It is non-volatile, it is permanent, but it is not a standard CMOS process. Okay, these are the three basic processes and a comparison statement to the one technology to the other technology. Okay, there are a number of things are there. I am not going to in detail to these things. Almost this completes our fifth model. Okay, next class I will cover a little bit things whatever the left over in the fourth model. On Tuesday I will wind up your entire syllabus. I mean, if time permits, I will go for the in the next classes revisions from the first model onwards.